So, shall we start the class?
Sir, we can start, sir.
Okay.
Sir, good evening. We can start, sir.
Good evening. Okay. We stopped yesterday in this slide, line deduction using Hopf transform. We know that when you connect the edges will form the boundary or outline of the any deducted object, because where there will be change in intensity level, light intensity level, which is called as edges, edge or edge points. Okay, if you connect the edge points, you will get the boundary. When you connect the edge points, you may get a straight line or a arc or a circle or a spline, different shapes. Correct? Edge of the object can be different shapes. So if it is straight line, because please note that we know that the equation for circle, equation for spline, equation for straight line, fitting, all those things already you know. For understanding purpose, we are saying one alone for
யாரோ மொபைல் வச்சுட்டு போயிருக்காங்க
line
அப்படியே வச்சிருக்காங்க.
I think there is some background noise is there. And
Sorry, sir. Sir, for my side only, sir. Sorry, sir.
oh, okay, for no issue, no issue. I don't know from where, somewhere it is coming. Okay, so line deduction very popular. What a Hopf transform is one of the method used for connecting or fitting line, right? Straight line fit. If there are 2 points, you can connect it. Hopf transform is used to technique the lines. It not only straight line, it can other also, but I am trying to talk about straight lines here. Okay, Hopf transform can be used for any type of line, but I am talking about straight line. This one popular method. So in the image, if we have edge point that can be transformed into a line using Hopf transform, Hopf space. So when we talk about straight line, we know that this graph shows the straight line is a two-dimensional. This one we are talking, correct? X and Y, in which we know the equation for straight line y equal to mx plus b, and here m is called as slope or sometimes which can be deducted by rise and run. Horizontal line, this value is called as run. This value is called as a rise. Rise divided by run is going to give m, nothing but a slope. Right? Any line will have a slope. Right? And by having some distance also. Now, here we know that the Hopf transform is the most common used method for deducting. Hopf transform is a technique which can be used to isolate the features in the particular shape within the image. I told you that when you do the thresholding, right, by setting this threshold, when you do segmentation, after that you are going to get change in intensity level, which is called edges. Edge can be points or multiple edges are very close. We can say that it can be edge array, different name, but it is nothing but a change in intensity, which actually represent a boundary. Please note that change in intensity can be noise also. That's why first we do the filtering. Try to remove as much as noise possible by using filtering technique. Then we do the histogram. By doing histogram of the given frame or image frame, then we'll find out what can be the T value, threshold level can be set, which will be used for segmentation. When you do segmentation, automatically you deduct the edges. Edges will be automatically identified. Change in intensity level between two nearby this one. So we already saw the different type of edges, but when you do filtering, automatically we saw that there are 4 types of edges are possible. Correct? So step edge, line edge will be there. If you don't filter, there are chances. If you have very sharp images, you can get. But when you do filter, many times it will become a ramp type or roof type. There's no, but still there's a change in intensity level. Right? This is intensity level. So there's a change is happening. Right? So now by connecting the edges, you get the boundary or contour of the object. The contour can be a straight line. That's what we said. We will do different lines can be possible. And we are talking about this one. So when you talk about this one, any shape will contain, the edge can have different type of lines, straight lines, spline, arc, or a circle, something that we can use this. Hopf transform is the most commonly used method for deduction of regular curves such as lines, circle, ellipse, anything can be deducted. You can Hopf transform. Here we are talking about finding a straight line fit between 2 points. Okay, when we talk about straight line, we know that this is the equation for straight line, where m is called gradient or slope of the line, b is called the intercept on the y-axis. Correct? This is origin 0, 0. So this is the x is increasing, this is y is increasing. or you can write like this. Y can be given like this. Whatever you do, but that can be this one, where the line intercept the y-axis is called as B. In this, B is called intercept at y-axis. So line can be like this also. Right? This is 0. Here it is intercepting. Right? This is the line, and this is intercepting. Correct? It can do, or it can go like this also. So this is the B value. Right? It can have, line can have positive slope or negative slope. Okay. So now, in which the B, how will you find it? B intercept can be found. One, see, there are this is the Y and M and X. This is x-axis value, the y-axis value. This is M is slope, B is the intercept value. If these things are known, automatically you can find out Y value. Correct? So then you can connect the line. Or if you want to find the intercept, you can find the using this formula. Same formula only, we have written a different form. Now, how the Hough transform can connect two lines or deduct a straight line? Line deduction using Hough transform. Okay. While you talk about Hough transform, you talk of two things. One is called image space, other one is called parameter space. Okay. You know that Y equal to mx plus b. That's what we saw. Right. So in this, M is one parameter, B is another parameter. Correct? X is represented. Parameter space is represented by B and M. Okay. One of the then for different value of Y and X, you can you know that you can plot for different value M and B. You can get different like B. One is red color line, other is blue color line. Then you can get by substituting different value, you can get the B value. And when you do that, now before coming back, how do you going to get this value, this M and B, from the image space? Correct? In the image space, you have 2 points. This is, I say, P1. This is P2. Correct? P1 is X1 and Y1 represented by X and Y. P2 is X2 and Y2. Okay? So we know the equation is one. From this, once this is there, if we are given a set of edge points, the P1, P2 are called edge points. For example, these are the edge of the object. Correct? 2 edge points. After doing all the segmentation, all those things, you have 2. But now you want to see whether you can connect both using a straight line. That's what you are trying to see using Hough transform. So now, if you are given a set of edge points or a binary image indicating edges, we are talking about straight line. That means line will have 2 edges, end. Correct? Straight line will have 2 ends. The end points only we are talking P1, P2, which is called as a edge point in case of this one. Now, then we can find many lines that can connect these points in the edge. So you can see that different lines are drawn. You can, with a different slope, right? You can draw infinite number of slopes are possible passing through this point, right? Like this you can draw, you can like this, you can draw any number of this one. Here a set of points are this one has shown, lines are shown, which is passing through this point. Okay. Similarly, you can draw for P2 also. P1, P2 you can draw. Now, when many lines are possible, that's what is shown here. P1, P2 with many different lines passing through the edge points, or which is not P1, P2. Now, if there are 2 edge points, X1 and Y1, X2, Y2, that's what we shown here. Okay. Then each edge point at various gradient, correct? So that's what I say slope. Slope M is not, this is one. We know that whenever you talk about slope, it is always with respect to angle with respect to x-axis. X-axis taken as 0. This is theta. That is nothing but the angle of the slope. Correct? So that we always talk like this only. Now, we have drawn many with respect to this, the x-axis. This is already x-axis there. We have drawn many lines with having different m value, slope value. Right? Now, here what they shown is, for example, m equal to 0.5, 1, 1.5 for the different slope value. Correct? They have drawn lines. They have drawn lines here, 1, 2, like that. Similarly, for this also they were driven. Okay, so we can calculate corresponding B value. B value is nothing but intercept value. When I change this one, for example, if I take this is the B value. For example, m equal to 0.5, for example. For that, this is origin. For that, it is cutting the y-axis at this point. If I take this, it cuts here. B value is correct. So now these for each point, correct? For each point, I am drawing the lines with different m value or gradient or slope. That means you m is you said 0.5, right? Then you are calculating B value. Already you know the B value. You can calculate B using this formula. You select m, you know, you as per this is concerned, you know the x value, you know the y value. X is known, y is known, correct? And now slope also known, correct? Slope also known, correct? X1 is known, some value, y1 is say yy, this is xx, this is known. Automatically you can compute B. Then you can plot m versus B for each slope, correct? That's what we are given. For this point, we are drawing different value. This is called parameter space. Your points are there, or edge points are there, image plane. For that, you take different m value, calculate B, then m versus, this is 0, 0, 0, then you plot. So for this point, you are drawn points, calculated for different m value. It is a continuous, but basically you cannot do by infinite number of possible. So m value can vary from 0 to infinite, correct? It can go to the, so for different m value, we say in the steps of 0.5, correct? 0, 0.5, 0.1, 1.5, 2, like that we are done. For that, we are calculating B. Then I am plotting that value in this parameter space. So then you will get this blue line, correct? Similarly, for this point, you draw that, correct? You know that for particular this one, M and B value, both these two parameter space, these two lines will intersect. This is nothing but B we are calculating, right? For different value of M, and x1, y1 is fixed. M alone is varying. In this, we are varying M alone for different slope. So then we are now, if you see that these 2 points, the lines in the parameter space will intersect a particular value of M, they will intercept. Correct? So that is what this. Then you can use that value, you can connect. This is how the Hopf transform works. Correct? Between 2 points. So then if you connect that, but if you have the same slope, automatically you know that that will pass through both the lines. For this value, M, correct? Both the line will the line, if you connect the line, they will align. The slope will be same slope. Slope for both will be same only. So then you can fit the, that's how the Hopf transform works. Correct? Now, the line can be expressed in terms of the polar coordinate system. A line can be expressed in terms of polar coordinate system also, correct? Rho equal to distance from the origin, correct? So this is my, this one, 2 axes are, correct? This is origin. From origin, there is a line passing, correct? You have 2 points connected by line, correct? From origin, you can connect by a vector. Okay, so rho can be calculated if x and y is known and theta is known. This is the theta. Then you can calculate this rho, which is nothing but distance between the line and the origin. Okay, then given an input in the binary image, say for example 30 pixel by 30, with edge points at the 2 location. One edge point is the one edge point. This is another edge point. Okay, so we shown in figure. That's what we are shown here. Okay, there are 2 edge points in this figure. This is one edge point. The okay, you can see that this is this, this is this, right? And similarly, this is this, this is this. 2 edge points. Okay. Then if you're connected by a line, that's what you have shown. Okay. The image is transformed into half transform. Right. This is image space. Correct. Input image. Correct. So that you want to transform half transform. Half space. They call half transform, half space. What we do is the image can transform half transform by calculating row value. This row you have to calculate. Okay. With the point at each angle from minus 90 to plus 90 degree, different angles. Theta is varied from minus 90 to plus 90. Then you can substitute, correct? For a row, you can calculate x and y is already known, correct? 1x is this one, the 25 is the y value. This is x. For that, you calculate and you can plot the curve. Similarly, for take the next point, then calculate. For the second point, you take it and plot. So this is the curve for the second plot. Both will come and intercept at particular value, correct? So the intercept point. So that you know that is the value for which you will be able to find the straight line fit. Correct? The point, first point, second point, you vary here we have shown only 4 value, correct? So here, then you can calculate this. It can be seen that the curves at half transform intersect at 45 degree with rho equal to 21. This point. They call half transform, half space, half transform. You see here, it is intercepting at 45 degree. Okay. So curve generated by collinear points in image space intersect rho comma theta in the half transform. Correct? So then the curve intercept point has more votes as a line will receive if you pass through that. So again, to further explain, the line detection of transform, the same thing we are talking, corner or edge detection. The result of binary gray image will have zeros indicating the non-edge, ones indicating a edge. Correct? Generally, we know the segmentation you do, wherever edge is there, that will be represented by 1. Other points will be represented by 0. Because we are talking about binary image. When you do segmentation, finally you will get binary image, will have 0 or 1. Wherever edge point is there, that will be represented by 1. Other points, which is not edges, they represented by 0. Okay. So this is input a half transform. You are going to transfer after segmentation. What do you do? First thing is you take the image, convert into, for example, if it is a color, black and white, nothing, color to grayscale image. Already you know, we saw the method, 3 methods, conversion. After that, you do filtering to remove noise. After removal, you do histogram analysis to find the T value, threshold value, correct? Then do segmentation. Segmentation will convert the image into binary image. We know that the value above the T value will be represented with 1. Value less than 1, the T value will be, for example, you histogram, you find what? We know that the grayscale value. I'm just trying to summarize. Grayscale value is vary from 0 to 255. 0 means black, 255 means white. Okay. Your image, you did histogram, it says the peak value in the image gives something like this, say 125. So you said T equal to 125. Correct? Now you use this value and do segmentation. T value, what you will get? A binary image. Correct? Wherever there is this one is there, the value edge is there. In binary image, edge will be represented by 1. Other pixels will be represented by 0. Edge will be 1, other will be 0. So now that binary image will be given to your half transform. That's what we are talking here. Correct? That means you have dots. Correct? I have a frame, something like this. I have a circular object. For example, I will say that I have a circular object, okay, which is say red color. Circular object filled with red color. This is my background, BG. This is the object. Object color is red. Correct? I converted into grayscale image. What will happen? I will have a grayscale here. It is not showing other color, not possible. I think that grayscale I represent with the light blue. Right? So the background, right, will have some grayscale value. Then this red color will have some other value. I will say dark. You have to imagine that I converted the color image into grayscale image. This is one grayscale level. I say the grayscale level is 50. Correct? This grayscale level is say 150. Okay. Then you pass it to histogram analysis. Then you get the histogram with one peak. This value, I say that 125. I will use this 125 as a T value, threshold value, do segmentation. Then I will get a black and white image. Background is white, right? But what you will get is immediately you won't get this one when you do segmentation, right? Thresholding, if you do, what you will get will be, just a minute, edge points. First thing is you will get edge points. Correct? You will get edge point. Now, this is a binary image, correct? Having edge points. Now I send it to half transform this one. What it will do? It will connect. It's a curve fit. Correct? Already I told you, you can use half transform to connect the edge points. Correct? To make straight lines or circle or ellipse, everything can be done with half transform. I am talking only at a straight line. Half transform, how we did like this. Correct? So when you do that, automatically you will get the final image. So now that you have detected the object, you can fill the with black color. That's it. The final image is I am able to detect the object, which was a red color. Yes, I am able to detect. Your computer cannot do it. Now, while you do, once edge is detected, we know that that is not the profile or contour of the object, which is a circular in shape. So if you supply it as a half transform, it will automatically connect the dots and make a circular. It will make a circle. Then you fill the inside the circle, the area you can fill with black. Then you are identified. This is identified object. Okay. So then you can compute the rho and the theta. You vary theta 0 to minus 90 to plus 90. Calculate rho. Correct. So plot the rho values. Let me use different color. But see, this is 90 minus 90. Right. This is this one. I calculate. For example, this is 25 minus 25, 1 point. Like the 0 to connect one line. Correct. For the second, for the first point, we have calculated the half transform phase. Then for the second point, this is point 2. Point 1, point 2. For point 2, again you calculate, connect. It will intercept on 1 point. Right? For that value of rho and theta, you can connect both the 2 points. That means this is how the straight line fit. This is a computer. Computer uses the equation. The computer equation uses this method to find whether both the lines are aligning in a straight line fit, at what angle, at what slope. That's what you are trying to find out. So now you are connecting. You are able to connect. So like this, if you have multiple points, you connect it. So please note that each between 2 points, half transform will be done in the binary image. Correct? Then next to 2 points, you will try to see whether it can be connected. Everything computer does in quickly, millions of instructions. Correct? That's how it does. optimal way it will do. Okay. So then at the hub accumulator, once you calculate theta and rho value, they are stored as a two-dimensional array. Correct. Please note that the steps you see, the what it does. Correct. Corner diagram, first you get the binary image by thresholding, which you call segmentation. Segmentation using threshold. Using T is threshold. Then you get binary image. The binary image you pass to the Huff transform. First, what it calculates, it varies the theta value 0 to say minus 90 to plus 90. It calculates rho. Right? Then accumulator of this value will be stored, which is called an accumulator. It is a 2D array with the number of rows equal to number of row value. Correct? Rows equal to rho is the value we are calculating, and number of columns is equal to theta. For different theta, you calculate. See, we have shown only 2 here. Please see that we have calculated only for 90, 45, 0, 40 plus. This you can do for different values. Correct? Then that will be stored in a array, 2D array. That is called accumulator. That is the word they are using. Huff accumulators by calculating rho for different theta for each point. We are going to have 2 points only, right? Then voting in accumulator for each edge point, for each theta value, find the nearest row value and increment the index by in the accumulator. Right? Next one is called accumulator. Will start like this one. It will start with I say accumulate A equal to 0. First, what it calculates for each edge point. There are 2 edge points here, but in this one you will have millions of maybe hundreds of points. If I say that this is 1 point, this is 1 point, this is 1 point, so each point you have to calculate in your frame. Right? These are edge points. It can be like this. Correct? For each edge point you have to calculate. Say start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Correct? That this is available in the edge points. See, whichever value, see, these point alone will have value equal to 1. Correct? You have, for example, 100 by 100. Correct? This is this one. So that means 10,000 points are there, pixels. After doing the thresholding, wherever the object edge is there, intensity variation, those points alone will have 1. Other points will have 0. For example, out of this, maybe say 400 points has 1. Remaining points out of 10,000, 9,600 points are 0. That means this is 0. This is 0. This is 0. Wherever the point is, those alone will have 1, 1, 1. For each one, you have to find this row value by changing the theta. Then you store that as an array. Then try to find, correct? Voting first. Your next thing is which one to connect. How do you know which one is neighboring point? Which is this one? But then what you will see is each edge point find the nearest row value, increment the index for that particular value, accumulator. Okay. Then for each element tells how many pixels contributed to voting for a potential line candidate, that whether there are the edge point like this. Right? We know that if I calculate the row for this, row 1, row 2, row 3, correct? These will all have same slope with same row value, nearest value. So that means I can connect not 2 points, all these points. That's what I am talking. Correct? Which lines can form a straight line? Correct? 1 pixel, 2 pixel, 3 pixel. You cannot connect this because these have different slope. This point has different slope. There is a point here, correct? Edge, but that is not in the straight line. So which and all point you can connect? That is called voting. Right? By finding the row value. Then peak finding. Find the local maximum accumulate indicates the parameter most prominent line in the input image. Peaks can be found most easily by applying threshold and relative threshold. Already we know that. Right? This is how you find this one. If you want more detail, you can see in the books. But this is basically how it works. At least, but connecting two lines, how it works, we understood, correct? So with this, because the image light-based sensors are most important sensor in autonomous vehicle. First one is camera, correct? Next one is lidar, correct? Camera gives more detailed image, but computational intensive, but it can detect color, correct? It can and also grayscale level with having highest spatial resolution. Spatial means what is the smallest distance it can find. That depends upon number of pixels. Higher the camera pixel number, it can see the finer detail of the object in the scene. But more number of pixels means more computation. You see that, correct? You have to find each and every pixels conversion, color to grayscale conversion, thresholding, apply the thresholding. We saw here, if I have 10,000 points, each and every point will go through your this equation algorithm. It has to find the slope, rho, theta for each and every point, correct? The edge points. Filtering already we saw. Mask has to be shifted. We are talking just 100 by 100. But actually this one is, if I take HD camera, this is maybe 1200, correct? So multiply this 40 megapixel, 100, 40 into 10 power 6. So you see how much computation you have to do. Right? Image processing, there are 6 steps to detect an object. That also you have to do in real time. Please know that you have to do real time. How? Minimum frames are 20 frames. Correct? Minimum 20 frames per second a video camera we has to take. Already we saw relationship between what should be the minimum speed. Already we talked about it, because that's why I'm repeating. Correct? This is very, very important. We saw that. And the camera will saw in the previous in the previous slides last week, correct? We saw that frame rate versus speed, braking speed, all those things, correct? And other one also we saw all those things are implications. Higher the resolution, higher the, that means a pixel, number of pixel. 10 megapixel is better than 5 megapixel. 20, 40, spatial resolution, we call it spatial resolution. Smaller changing this one, profile of the object can be detected. But it involves highly computation. You need a CPU which has more power. It will consume your battery power, correct? Your vehicle power is given from the engine or from a battery, correct? So it is going to consume petrol or battery power if you use high speed processing this one. So less, if you're using the optimal camera is very important. Whether you have to use 1 megapixel, 5 megapixel, 10 megapixel, or 50, 100. Already we saw, what we saw in the previous class, the research 10 years before the what they told, 1 megapixel or 4 megapixel more than sufficient for autonomous vehicle for detecting objects, line marking, the lane marking, and signals and road signs. Everything can be detected with 4 megapixel itself. The research shown that 1 or 4 is sufficient. That was 10 years before paper, correct? That's what I want to show. With this, I close this. Okay, the image processing. Next, we will start with new topic. Most important, another most important. Everything is important. Next, what we are going to see is communication system. Correct? There are 2 types of communication system. First thing we will talk about a wired communication system. Okay. Let me share the new slides. Able to see?
Yes, sir.
Yes, sir. Yes, sir.
Just wait. Even before this, one more I want to show another PPT. Vehicle communication system. There should be one. Let's see. Just a minute. I wanted to find. Yeah, I will say this. This is better. One minute. Let me close other one. There are two slides. Visible?
Yes, sir. Yeah.
Okay. When we talk about vehicles, because vehicles are not stationary, it is meant for moving, right? Keeping inside my garage or inside my shed is not work. It has to move most of the time. In fact, you know that no, there is a joke, or in the lighter sense, one of the worst investment in the world is buying a vehicle. Right? You go and ask any economist, correct? They will say the dead investment. They call it not investment, they call dead investment. If vehicle is not moving, you are wasting the money. Buy your Mercedes Benz car, 1 crore, keeping in garage most of the time per day. You start weekly once you start and go around the city, show the vehicle to your friends. Say, I have Mercedes Benz. That means you are wasting around 99 lakh rupee. After 10 years, the value will become zero. 1 crore is gone without use. They say it is a dead investment. But we are all working on autonomous vehicle. We should not tell this secret outside. Then nobody will buy our car. Right?
Right,
Don't
sir,
tell this
sir.
outside.
Then every car company will close, sir.
Yeah, no. You will lose job. I will lose my job. We are starting the autonomous
That is a
vehicle.
theory, sir.
Okay, but no. This another thing, secret, correct? We'll say that open secret, people. This secret is known to everybody, but still they buy it. Don't worry, correct? Even if you go and announce in TV, people will buy it, correct? That is a human tendency to have some luxury items, correct? So fancy items, something like that, whether useful or not, correct? So that's why some cars started only 120 years before. Now they say there are something around 4 billion vehicles, correct? Or at least 500 million vehicles. Are correct? Old vehicle, new vehicle. So nobody going to stop, but still we should not tell outside, correct? So our job is at stake. Better not to tell outside. You encourage them to buy. You buy sports car, bigger car, this car, that we have to do. But it is a dead investment as long as it's not moving. That is very important.
Right.
Right? If you are not going to use the vehicle every day, don't buy it. Another thing they call it what they call carpooling. Correct? What they say is carpooling means I take my, for example, you are working, you have a car, spend around 25 lakhs or 20 lakhs. You start your car, go to your office. After that, somebody should drop you in your office, or you drive your car, somebody come with you, give the car to him, let him use for his maybe your wife, she want to, or your son, you want to go to college. Like that, they want to use the vehicle throughout the day as much as possible. Everybody use, they call carpooling, correct? Maximum efficiency, correct? Someday it is not possible, but these are all theoretical, this one. Fine. That's different. Okay. So why I said is car is a moving asset, correct? It is not going to be stationary. No. In car, you have many subsystems, electrical subsystems or mechanical subsystems, which are controlled electronically. Correct? We know that our vehicle consists of lot of electronics and sensors and control system, which is controlling mechanical system, including brake, steering system, engine. Without that, the car cannot work. They are all mechanical system. IC engine, correct? Brake is a mechanical system. Steering is a mechanical system. But now we are trying to automate. So we have put more sensor, more controller, more actuator. Steering system actuated by electric motor or a hydraulic motor. Engine is controlled by fuel injector. Correct? Electromechanical injecting fuel. Right? Then brake is controlled ABS with hydraulic brake, correct? Piston, cylinder, and valves. All those things are controlled. So these things. Another thing is these systems need to communicate with each other. They have to work coherently. Correct? When you apply your brake, automatically when you press the brake, when driver presses brake pedal, correct? Automatically he will take, if it is a manually driven car, he will take his leg from the accelerator pedal and also try to avoid sharp turning, right? If you turn your vehicle simultaneously apply brake, the skidding can happen, correct? So first thing is reduce speed, correct? After that, if then you apply brake, simultaneously try to reduce the oversteering, and all those things you do. So that means that is how you are doing manually. You are doing brake pedal pressing, clutch pressing, and brake pressing, steering control manually. All this thing has to be done at autonomously in case of autonomous vehicle, because there is no human. That means the ABS, steering control, and brake control are controlled by a vehicle controller. Correct? Vehicle controller decides whether to apply brake, accelerate, decelerate, depending upon the environment, looking at the road. Using camera, lidar, it takes the picture and find out whether object is in front of it or is a moving object, stationary object. All these things like a human assess. Accordingly, it generates control command, main controller, vehicle controller, the autonomous vehicle controller, where you are going to put all the algorithms, path planning algorithm, object detection algorithm, all the program. Those algorithms will run using data coming from sensor. Which sensors? Camera, lidar, ultrasound sensor, radar. These are the 4 sensors which is going to act like your eyes and ears. So to perceive the environment, perception, correct? It perceives the environment and then using algorithms, it knows whether to press the accelerator. There's no pressing accelerator, directly give electrical command signal. Main it will give control to the engine control, ECU, inject more fuel, accelerate, or reduce injection. But please note that injection is not controlled by vehicle controller. That's what I'm talking. You have vehicle ECU. This ECU is going to control 3 more. And main this one, right? So engine, ECU, steering ECU, finally the brake ECU. We are talking ABS. These 3 are going to control the engine. Engine, steering system. Please note that bottommost is mechanical system. Correct? This is brake. Correct? This is the mechanical thing controlled by electronic circuit. ECU is nothing, electronic circuit, all those things, in which then the whole thing is controlled by another electronic circuit. Correct? Vehicle ECU. All these things will have software. Correct? These are electronic hardware. This is a mechanical hardware, software algorithms. Correct? Whatever we saw, image processing, again program only. You write lot of software. Correct? Filters, filtering algorithm, edge detection algorithm, hub transform, all these things you write as a program. That program will be running here. Correct? So this is the vehicle master, which is nothing but autonomous vehicle controller. This is what going to replace the human driver. This ECU should have all the capability of human driver. Take the picture, analyze, take a decision, correct? Now, this software, now we are upgrading with artificial AI, deep learning, algorithms, which is called AI, which will work like a human brain, right? Now from this, what you understand is, one more thing I just add. We'll see in the next slide itself. Okay, this is a typical vehicle, correct? A typical high-end vehicle. We are talking about car maybe costing 50 lakhs to 1 crore, not 10 lakh, 50 lakh car. In a typical vehicle, high-end vehicle, there are maybe 20 to 40 ECUs, electronic control units. Correct? ABS, one electron, there's a microprocessor, there's a program, that is separate ECU. Correct? Engine ECU, brake ECU, body electronics, infotainment electronics, correct? Traction control. For each and every seat, smart seat, adjusting seat, all those things, air conditioning control, climate control. Like that, there may be up to 20 to 40 ECU. If I told you, I don't know, if you take any vehicle, current vehicle, mid-size vehicle to high-end electric vehicle, which costs 5 crore, 40 to 50% of the cost goes to the electronics alone. 1 crore, if I say that, if the car price is 1 crore, up to 30 to 40 to 50 lakhs. Current high-end vehicle, the software, the electronic hardware plus the software development. If somebody says, I am pure mechanical man, you bought a Mercedes-Benz, correct? Or some other car, paying 1 crore. Suddenly you realize that, hey, this car has a lot of electronics. I don't want electronics. I am pure mechanical man. There are people talking like that. I have seen a professor talk, I like mechanical, nothing can beat. You was talking like that for many years. Now finally end up with electronics. Nothing else he can do. I know him for a very long time. Mechanical world, that is the mother of all engineering. Nothing, I do this, all this thing. Finally, he ended up talking about electronic control, electric vehicle. Correct? You cannot survive just with mechanical. I told 40 years before, 35 years before. That time he didn't agree. Now he preaches me. No. Without electron, nothing can go. Correct? So what I'm just saying, lighter sense. The 40 to this one, why means if I remove all the electronics, that's what I'm showing this figure. You remove all the ECUs, the sensors, all these things. Your vehicle is a dead mechanical junk. Engine won't start because fuel injection, ECU removed, injector removed, the injector, driver, electron, everything removed. Engine cannot start. No carburetor, nothing is there. Correct? You can talk, I can carburetor, but if you put a carburetor, you cannot sell the vehicle. You cannot meet Bharat 6 standard. With mechanical system, correct? With your without the fuel injector, correct? Where you can control fuel quantity in milligrams, correct? Whenever you want. Already we saw that fuel injector, CRDA, GDA. Without that, you will not meet Bharat 6 standard, CARB 6 standard, Euro 6 standard. You cannot sell the vehicle cannot come out of your factory gate without the Bharat 6 standard. This one, no, you can't drive it outside the road. Except maybe you can test inside your factory only, go on roaming. You make 1 million car, inside your factory only you can drive. You cannot sell it. Right? Worldwide. So mechanical things not possible. Without ABS, you cannot go to 120, 150 or braking. Correct? If you are a race driver, you can say, people argue, correct? Race drivers, 50 years before, car race was there. Ferrari, all those things, McLaren, all those things. Yes, I have watched for 40 years, correct? But only in racetrack you can drive at the speed of 120, 200 kilometers. You go to Google, correct? You ask for the sports car, testing German highway, public highway, 240, 300, motorbike, you know that, correct? Indian roads, people are driving motorcycle 200 kilometers with the ABS. Fuel injection, ABS, motorbike, 6-cylinder, 4-cylinder engines, correct? All these things are possible without, because electronic mechanical thing cannot do it. But no, that's what our interest is. We know that. Again, I'm repeating. If you don't want to, you say that I won't learn electronics, it is difficult and software is not possible. The fellow who learns software along with mechanical will become your boss. His age may be 30 years, you may be 50 years, you'll be working under him if you don't learn electronics and software. That's what the future. That's why the course itself, correct? The company understand, you understand, I understand as a professor. Future is mechatronics. Future is mechatronics. It has started 50 years before. Now it become more and more. I always say penetration of electronics, sensor and software is becoming more and more. In future, the cost of the vehicle only for 30-40% mechanical, remaining will be software, electronic control, because more sensor, more software. Software development is not easy, correct? You know, the software engineer. I will tell you the truth, correct? Whether you like it or not. I worked in Caterpillar, I worked in a Ford as a software engineer. I have seen the same company mechanical engineer. My salary was 3 times of mechanical engineer, 2 times of mechanical with PhD. I had only MTech. I had MTech, but I was a software engineer development, correct? The mechanical engineer working in the company had half of my salary, but the experience was 2 times of my salary. This I'm talking 20 years before. Now think about it, correct? So better we learn electronic software also, but of course we need mechanical also. We need mechanical engineer also, but you need to understand. That's why the course we are talking. Next semester I'm going to teach about maybe at the third summer, fourth summer for you. I'll teach mechatronics, correct? How to integrate electronic sensor, mechanical system, how to design. That is the core elective course I'm going to teach you, right? All the previous 4 batches I taught. Again, anyhow, I'm going to teach also. Now, coming back here, vehicle. In the vehicles, there are 2 types of communication. One is called wired communication. Wired communication system. Other one is called wireless communication system. Okay. For autonomous vehicle, you need wireless. Very, very important. Wireless communication used. The wired communication is shown here. That is also called in-vehicle communication system. Another name for the wired communication systems are called as in-vehicle communication system. Okay. You can see here this picture, very nice picture. I took it from internet, but they very clearly show in wired communication means there are 2 ECUs. I told you the communication is needed for talking with each other. Which one is going to talk? 2 ECUs, 3 ECUs, 4 ECUs using a set of wires. Correct? The wires is called communication bus. Wires connecting 2 ECUs called communication bus, BUS. Correct? It is not our bus which we are traveling. We will see what is a bus, all those things today, subsequently. Okay. There are in wired communication, in autonomous, because there are many things we are going to see, but most important thing is there are called a CAN bus. Other one is called LIN bus. Other one is called FluxRay. These 3 are called 3 most widely used communication, wired communication buses or systems or protocol in autonomous vehicle. Okay. So we are going to see these 2. FluxRay, I'm not going to talk. I will just tell what it is. It is very high speed communication, but we don't have time to discuss all these things. But these 2 is sufficient. These are very widely used. This is used for entertainment systems or infotainment. They call infotainment or entertainment system. Correct? Music system, TV. Correct? You will have in front of driver there's a display. Correct? For rear end passengers you put TV. All these things you are going to communicate the same thing. All these things for where the data transmission will be in the order of hundreds of megabytes to 500 megabytes per second data. So high speed communication bus is FluxRay that is used for entertainment. So I am not going to talk about this, but remaining 2 bus we are going to see in this course. Correct? CAN bus and LIN bus. Okay. So now let's see this picture very clear. You have body electronic control. Body electronic control is nothing but for your doors. Correct? If your door is open, engine won't start. If your boot, correct, your boot is open, the doors are open, correct, the engine should not start, correct. That is a modern. So these are all connected to body electronic system, correct. Vehicle body has sensors. Whether your boot is open, front door, back door, this one, or the front, this one is open, engine, bonnet is open. All these things they put sensors. If the door is open, all these things, it will go. This ECU, body electronics unit, will give you a command to engine ECU, don't start. Even if driver presses, you press the start button, your ECU will say the error indicating it won't start. Okay. Then climate control, light control, correct. So you know that the light can generally light will go like this, correct. Generally beam. Now if you are taking a curved road, correct, if it is showing like this, but what you need is here you want to illuminate, but still you are about to turn, what you are seeing is here only. But now there's a smart lights are there, correct. As you turn your steering, your beam also steer along with you, correct. If that means your steering sensor signal is also used by smart headlamp controller, which will steer the angle of beam, so that always it shows the maximum light for the driver to see this one. So like that, light control, correct. Climate, AC control. Then seat, correct. So you need that now. Smart seat. Smart seats are available. Go to high-end car. I think even around 25 lakhs, 30 lakhs. I told Creta has, I think, and even the Honda City, Volkswagen high-end cars, correct. They have ventilated seat, they call it. But they are not small. Go to BMW, Mercedes-Benz. You know that the seat can be adjusted, height can be adjusted. It can move to front. Because I have Amaze. In Amaze, I have the levers. If you pull the lever, seat height can be. Another lever is that if I adjust, I can inclination, I can change. All manual control. Instead of that, they put motors, correct? To adjust height, to adjust all this thing motor. These motors are controlled by ECU, another ECU, electronic control unit. This now, if I, for example, I buy my car, correct? I know driving, my wife knows, my son knows, correct? So we know that all are not same height, correct. Height is different, correct. Comfort level, where what position the seat should be there. I'm talking about driver seat. So when I buy a car, what I do, I just first time when you go inside seat, you will adjust. Generally, you are supposed to do that. Put the seat belt before starting this one. You adjust your seat height so that you can see in front properly, correct. The angle, all these things, seat adjustment. Instead of doing manually, the high-end cars, BMW, all those things, in there's a button in your this itself, key, vehicle key itself, where you can adjust the height, all those things, or desired height, then you can memorize. That value can be memorized. Okay. So you such this. Now you use the car, you came and put in garage. Then your son goes, he is taller, for example, or shorter. He will go, he cannot say that seat is not comfortable. What you will do? Again, you will adjust the height, all those things. Correct? So now next time if you go, again you have to adjust every time. Instead of that, in the smart vehicles where they have this one, when you adjust, you have 2 or 3 memory. Correct? So the D1, D2 like that. Correct? You can store it. The information can be stored. So I adjust the seat, I store the information. Right? Now your son goes, or with this one, my son goes, he adjusts. My wife goes, they adjust. Every time they memorize. Now, next time when you go, you need not adjust every time. You press the button, the D1, something like that, which is stored. Automatically, the motors will adjust the seat for you before even going inside the vehicle. Correct? You can do that. So there's another ECU. Correct? Seat adjustment. Like that, window heating, trunk, correct? Lights. I told you like this. Heating system. Correct? Interior heating, all those things. You can see that there are then infotainment system. Infotainment system is speaker, music system. There may be a TV, correct? Speakers, radio, vehicle computer, navigation computer, correct? So GPS, CD, correct? Music player, your cell phone connected GSM, you wanted to connect with this one, all these things. So different type of buses are there. Okay, there are 3 type of buses. I told you, one is called CAN bus, other one is called MOST bus. Another thing, apart from FluxRay, correct? FluxRay is there, MOST. There are 2, this one. These are high speed. They are competing with each other. So some vehicles are using MOST bus, some vehicles are using the FluxRay. What for they use? They are high speed bus. They are high speed buses. High speed bus. That means 500 megabits per second, MB. Megabits per second, MBP. Correct? 500 into 10 power 6 bits can be transferred in 1 second. Can go even go to 1000 into 10 power 6. Correct? 1 gigabits. That's possible. Correct? So that kind of information needed only when video, dance, music, all those things. For that, they are using MOST bus. That is shown in, you see that in the brown color. Correct? MOST bus is connected to the speakers, music system, CD player, all those things. Okay? Again, it is a wired bus. It is a high-speed bus. Next to bus is CAN bus. CAN bus speed can generally can be 500 kb to 8 MB megabits. This is speed. CAN bus, the data transfer speed is this much only. So this is a medium speed communication system. Medium speed communication system. Okay. MOST is high speed. Okay. This I show 500 to 1000 MB megabits per second. Okay. Then next one is LIN bus. You can see that LIN bus is used for, is a low speed bus. Is a low speed bus. Generally less than 100 kilobits. KB, kilobits per second, KBP. Correct? 20 to 100 kilobits. Generally it works on this one. This is used for connecting some devices. You can see that the green color. Correct? Green color one is used for connecting heating, lights, window mirror, correct? All these things. These are connected by LIN bus. Here, there is no need for transmitting data at a very high data rate. Slow speed is sufficient, correct? Window opening and closing, whether door is open or closed, trunk is closed or open, lights, all these things, you don't need high speed data. So for that, the LIN bus is used. CAN bus is used for engine control, brake control, correct? Steering control, where the action should be done in milliseconds, correct? Closing the door, can you close your door in millisecond? Not possible. At least you take, even if you slam your door, it may take 5 seconds to close, right? Sensing all this, slow speed is sufficient. Dicky, all those things. Mirror adjustment, all these things, correct? Lighting, all those things is slow speed. But engine, brake, when you press a brake, already we talked about ABS, correct? You know that you are traveling 100 kilometer speed, correct? What is the, within 1 second, how many meters your vehicle will go? You know that 1 lakh divided by 3060, correct? At least 20 to 30 meters within 1 second, your vehicle will go, correct? If you apply a brake, immediately brake is not, you know, the braking distance will be 100 meter, 200 meter, only at 100 kilometer speed. If you apply brake, immediately that should be sensed. You press the no, your ABS, your brake pedal you press, there is a sensor in the foot. That should be sensed immediately by ABS controller in milliseconds. Immediately it should give a command to the brake shoes, the hydraulic system, and it has to modulate this one. The brake should be pressed and release. All those things should happen in millisecond. That means the data should be transferred in microseconds. If you have to transfer data in less than millisecond, then your bus speed should be, that's why CAN bus is used. Correct? Brake, steering, these are safety critical systems. Please note that. If somebody has talks in your safety critical system, is nothing but your brake and steering system. Correct? If your music system doesn't work, correct? For example, you press the your switch on your CD player, it takes 1 minute. Sky will not fall, nothing will happen. Correct? Your infotainment, your the cell phone is the DSM system is not working, or GPS is not working. Sky will not fall, nothing will happen. Correct? You may get irritated, but if your brake doesn't work when you apply brake within millisecond, when you steer the vehicle in your sharp corner, if the steering control doesn't sense that you are steering sharper, that means you are going to steer your vehicle very fast. Now, rate of angle, steering angle. If it's not sensed in millisecond, and if the steering assisting motor is not immediately actuated, your vehicle will go off the road, you will get killed. So that's why they call safety critical. Of course, engine also very important. When you are going 100 kilometer, vehicle behind also highway, vehicle behind will be coming in 100 kilometer. Suddenly your engine stops. Something doesn't work. What will happen? If it is not sensed immediately, correct? The vehicle can come, somebody can come and hit you. So they're all called safety critical. Brake and steering very bad automatically. So they are all connected by CAN bus, which is a medium speed. Medium speed is 500 kilobits to 1 megabit or 8 megabit. Correct? The latest CAN, original CAN of 500 kilobits, the latest CAN is 8 MB megabits. Correct? 16 times faster. Okay? Link bus is slow speed. And infotainment, here the safety is not important, but the data is huge. Video data is huge. Correct? Music data is huge. So you need a high speed bus. These vehicles are connected by this. Shall I give you a small break?
Sir, yes, sir. 5 minutes break, sir.
Yeah, thank you.
Thank you.
Yeah, thank you, sir.
Shall we start the class?
Yes, sir. We can start, sir.
Okay. Fine. So, as I told, this picture shows what type of communication needed to connect different subsystem controllers. We are talking ECUs, correct? So already you can see that here is at least 10 to 15 ECUs are there, correct? In high-end car, it can be even more. They need to talk with each other because I told you when you apply a brake, the fuel injection should be reduced. So the automatically the ABS ECU will send a command requesting, because ABS cannot control engine. Engine is control engine ECU only. So the ABS will request the engine ECU, please reduce the, I am going to apply brake. Correct? How much all this thing, the message may be continuously updated. Similarly, each other that you need data sharing. So for that only we need a communication systems or communication buses. Okay, sharing data between different ECUs inside the vehicle is done using wired communication. The CAN bus, the most bus and LIN bus all are using wires. Without wire, they don't work. They send electrical signal only in wires, like a binary signal, zeros and ones, 0 volts, 5 volts, like that, or 2.5 volts to 3.5 volts and or 1.75 volts. Correct? In case of CAN bus. CAN bus normally it will be 2.5 volts. When want to send, you know that data, please note that these are called digital buses, digital communication buses. That means the signal send will be having only two voltages, which represent binary value, 0 or 1. Digital means binary number, 0 or 1. 0 means it may be 0 volts, 1, 0 means this one, 1, which is called binary high, may represent 5 volts, or it may be represented by 3.7 volts. Most of the systems, they represent 5 volts. In some systems, it may be minus 12 volts to plus 12 volt to minus 12 volts. Right? 1 is represented by one value, 0. You say binary, 0 means I am talking binary value. That is represented by as a voltage. In electrical system, only voltage can represent the value. Right? So in CAN bus, it is 2.75 to 3.5 volts. One represents the binary 0, other is binary 1. In some other communication system, it is 0 volts or 5 volts. 0 represents 0, 1 represents 5 volts. Okay. So that's what we are going to see. Okay. Now, please take the information. This is, again, I told you, understanding is one. Exam also you have to write. You are expected to write important points. So the CAN bus. CAN bus is nothing but short form of controller area network. That is actual full name. Full name is controller area network. This was invented by in 1983. Correct? It is a for 10 to 15 years proprietary. Others cannot use this. This electronic circuit or communication. This one cannot be used because of copyrighted. It is a proprietary item. Okay. It was invented by Barabar 1983. Because you know that they are one of the leading company which supplies electronics and automobile systems, subsystems, sensors, spark plugs, everything, motors, right? They're leading supplier. So they developed this. So they call this controller area network CAN bus. Short form is CAN. Okay. So it is used for transmitting data, engine management system, ABS, steering, any other safety related system, where high-speed data is very, because action has to be done immediately. You cannot even wait for a second. 1 second is too long time. Correct? If you don't take decision millisecond, accident can happen. Safety is related. So data should be passed between ECUs in milliseconds. That's why they use CAN bus. The CAN bus, originally, it was developed with up to 1 megabits. Mbps of megabits. Mega means 10 power 6. Bits per second. PS means bits per second. We know that 1 bit is correct. This 1 bit, second bit, third bit. Already we talked about, correct. Detailed data is going to be transmitted 0 volts or 5 volts. So each one represents 1 bit. The duration, if it is 1 megabit, the duration will be 1 microsecond, sorry, 1 microseconds. We know that if the transmission, highest possible transmission rate of CAN bus when it was introduced was 1 megabits per second, 1983-85. That itself is very high speed. That time, this most bus was not there, FlexRay was not there, USB was not there, right? All these things were not there. We had what you call RS-232 and RS-422. Okay, and you can see that SAE-J 184. These buses were there that time. Okay, so when CAN bus was introduced, it was a very high speed bus. It can transfer data up to 1 megabits per second, up to 40. Now, the speed, we know that 2 devices can be connected by CAN bus with a 40-meter wire only. If distance is more than that, you cannot transmit data at this speed. You can transmit, the distance can be 500 meters in CAN bus. In that case, you can transfer only 125 kilobits only. You have to reduce the speed. Number of bits transfer this one. And you can transmit up to 1 kilometer if you want to transfer only 50 kilobits. Low speed. CAN generally, you get a high speed bus. But please note that inside vehicle, correct? What is the length of your vehicle? We see here. This vehicle, this total length may be 5 meter in case of SUV or sedan, luxury sedan. If it is a truck, correct? Maybe 10 meters length or 15-meter length, long truck, not more than that. So you can transfer data inside vehicle at 1 megabits per second with maximum speed. That's what I'm trying to say. Because it is used for in-vehicle communication. Okay. CAN bus is used for this one, high-speed data. Next one is called LIN bus, which is short form of local interconnected network. The short form is LIN. LIN, local interconnect. That is the full name. Short form, the LIN bus. This bus is used for data at low speed, like display, correct? Your dashboard display, correct? 7-inch screen which gives speed, all those things, right? Then lights, controlling lights. I told you lights can turn automatically. You can so change the angle of beam, correct, by changing this one, all those things. Then mirror, correct, side mirror opening and closing, power windows, backlighting, inside light. You can adjust the dimming, all those things, correct? Encoders, sorry, this is called encoders. There's small mistake. Sensors and encoders. The sensor, what a door. How the EC knows? In the door, you have a micro switch. If you open the door, the switch will open. It will give 0 volts. If you close the door, it will give 5 volts. The switches will be sensed. Those sensors, right? Boot sensor, correct? The door sensor, front door, back door, correct? If it is open, those there will be micro switches. They are micro sensors. Those sensors can be connected to the ECU, body electronic ECU. That will be connected using LIN bus. Already lighting, all these things, ECUs are connected. Generally, the speed of transfer, max, generally it's up to 40 meter, you can transfer. You see that 19.2 kilobits per second. Very, very slow, right? You see here, we are talking megabits. This is 10 power 3. 19.2 into 10 power 3 bits only. Here, 1 into 10 power 6. Correct? Compared to this, it is 50 times lesser. You can take round of 20 kb bits per second. This is 1000. Right? 500 times less compared to CAN bus. LIN bus is 500 times. It is slower, but sufficient. Right? Because door open, all the sensing, all the doesn't need high speed. The next one is FlexRay. It is used for steer by wire, brake by wire, all these things. For that, you see the speed is 500 kilobits to 10 Mbps. It is higher than the CAN bus. CAN bus only one. Here it is 10 megabits. Then the most bus, they call media oriented system transport. The short form is most. Correct? Most bus in a media oriented system, mainly used for connecting car radios, CD, DVD player, GPS, all these things, where high speed data, video data is coming. It can go up to 150 megabits, 150 into 10 power 6 bits per second, correct? BPS or megabits. Okay. Then the other one is very popular, is SAE-J1850. This is used in all American vehicles. CAN bus, correct? Please note that even in the industry, automobile industry, correct, some 20, 50 years before or 30 years before, they are isolated. All American companies, correct? You take GM, Ford, Chevy, all this company, they use SJ only. SAE. SAE, where the headquarters? Detroit. Correct? Those companies form a consortium, they develop their own bus. Correct? So all American car companies will be using this bus only inside the vehicle. You can use any bus. Correct? Please note that if you want to use this bus, there'll be this one you need to pay some royalty. If it is correct. So every country want to see that the money doesn't go outside the country. So they wanted to see that local company develop their own systems, all those things, right? Then if you see, go to European company, they all use Bosch, correct? All European car, starting from Volvo, Mercedes, BMW, most of the European company, please note that it is not that, don't come and say that American guys are CAN bus. It is there, correct? Initially, that the patriotism, you can say, correct? Japanese company, they all order of the, that all the ECU, ICs, they use from Fujitsu, correct? Then Hitachi, correct? Or Sony. They buy all the electron hardware, software from this system only. Sensors, all the Canon, Nikon, all are Japanese car companies. Correct? They don't want to buy any. See, the same camera will be available in Germany. Same camera, they don't buy it. But only thing is they are able to develop their own. They develop the technology individually. Each continent is able to. Korea, all that's happening. I'm just giving nothing here. We are not even. That's how it was working. Correct? So because that are proprietary item. Correct? Canvas are proprietary for initial some. Afterwards, now that now it's a global village. We call global village. Correct? So you from it. American company come and start your car factory. Ford is here. Hyundai is here. Correct? Apart from local companies. Correct? Yamaha, motorcycle, everything. Indian company going and Tata Motors has a factory in China. They want to have something in this one, Indonesia. They wanted to start there. Now everywhere we are penetrating. We are also trying to penetrate motorcycle company, all these things. Asian countries, European countries are exporting. They are exporting cars. I told you I saw a Santro car in 2013 in Italy. Right? I saw 2 Santro cars in Torino, right? More than 20 years before. That means they are buying. We are exporting. Fine. So this is what you want to know. Next thing is, what is this? When we talk about communication buses, wired communication, there are 2 types of wired communication buses. One is called parallel bus, other one is called serial bus. Parallel communication, serial communication. There are 2 types. Okay. So what is the first thing? We'll see what is the parallel serial communication. Then we'll go deeper inside the communication buses. In parallel communication bus, if I say that my 2 ECUs are there, correct? This is the ECU1, correct? And this is ECU2. These are connected by parallel bus, means you will see that each line represents 1 wire. Wire 1, wire 2. So how many? Because you can see that there are 8 wires. They are all connected parallelly. They're from device A to device B, they are connected as a bundle, 1 wire. So that if the data is transmitted bits simultaneously, I want to transmit 8-bit information from ECU1 to ECU2. We know that these are digital communication buses. That means data. Data of the zeros and one binary data. Okay. So in that case, we know that then there are 8 wires. First data I call it D0, data 0. First bit is called D0, D1, D2, a byte. Consider 8 bits. The lowest bit is called as D0, D1, like that, D7. You can see that D0 to D7. Now, what I want to transfer is this device wanted to transfer this data. This is data, binary data. Binary data 1, 0, 1, 0, 0, 1, 0, 1. Okay, that's what I wanted to transfer from bus A to bus, no, device A to device B. Okay, so this is the binary data. This is D0, this is D1, this is D7. You see that in the computer, numbers start from 0, not from 1. Always start at D0, D1, D. That is data bit number 0. Sometimes they refer B0, bit number 0, first bit. Right mode bit is called as LSB, least significant bit. Least significant bit called LSB. D0 called LSB. This is called a MSB, most significant bit is called this one. So together 8 bits called as a byte. Correct? In digital electronics, the smallest number is a bit. Bit can have only two things, two values, 0 or 1. It can have only true or false. Okay, byte consists of 8 bits. Correct? Like this, bit D0 to bit 0 to, we say B0, B1 to B7. Correct? If it's going to transmit data, we call D0, D7. Generally, we call B0 to B7. A byte consists of 8 bits. Byte consists of 8 bits. Then next thing is, next unit is called as word. In detail, like a word. Word consists of 16 bits. What is that? B15, B14, like that, B0, B1. This is the LSB. This is the MSB. Next thing is long word. Long word consists of 32 bits. Correct? What are 32 bits? B31, B30. This is the MSB. Right? The leftmost bit is called MSB. This is B29, like that. B0. Here B1. This is LSB. Right? You can have 64 bit also. That is B63, B62, like that, B0. It will have 32 bits. Okay. So this is how it represented. Now I want to transfer 1 byte. Byte by byte. At a time, 1 byte. 1 byte means 8 bits I want to transfer from this device, transmit device, I say ECU1 to receiving device, ECU2. Correct? If I want to transfer all the bits simultaneously, what I want to do? I want to do simultaneously. If I want to do, I need a parallel bus. That means there should be 8 wires. Right? If you have 8 wires connecting to both the device, that is called as a parallel bus. Okay. Now, instead of that, I can have same thing. Transmit device ECU1. This is ECU2. Correct? I can use only 1 wire. Same data I'm transmitting. Please see the same data I want to transmit. But how I am going to transmit is bit after bit. LSB is transmitted first. Give some time. Then transmit next bit. D1. Then transmit next bit. D3. Then last bit D7. That means I am transferring 8 bits from A to B, device ECU1 to ECU2 using only 1 wire. Again, but each bit to transmit takes, for example, 1 millisecond. Correct? It takes 1 millisecond to transmit 1 bit. So how many bits you have to transfer one after another? 8 multiplied by 8. What is total transmission time? 8 milliseconds. Okay. Think about here. All the bits are transferred simultaneously. Again, to transmit one bit, it takes only 1 millisecond. Correct? It takes 1 millisecond only. But you know that all the bits are transmitted simultaneously because you have separate wires. To transmit one byte, how long it take? 1 millisecond only. Within 1 millisecond, I have transferred all the information from device A to device B, 8 bits. In this case, you need 8 milliseconds if it's a serial transmission. So, from this, what we understand, parallel faster transmission, faster data transmission is possible. Transmission is possible in parallel bus. Here it is slower data transmission. This is advantage. Do you want to transfer the data faster, quickly? You want to quickly, as quickly. Anything you want to do faster. So parallel, if you use a parallel bus, I can transfer data quickly from device A to device B quickly. But what is drawback? You need 8 wires. Correct? Here you need only 1 wire. Okay? When that means you need a wire cable which has only 1 wire. Correct? This is 8 wires, a bundle of wire. So this is costly. Initial cost, the wire cost. Correct? So now, for example, we know the telephone lines are there from Chennai to US. Still it is there. Telephone is still there. Going across Chennai to Bombay, Bombay to Karachi, Karachi to Aden to London. Correct? From London to New York. Cable is there for last 100, at least 70, 80 years. Telephone. Now only you have the satellite phone, cell phone, all those things. Correct? 30 about only regular standard. They are using serial communication. So in telephone, how many wires you have? One is earth wire. Correct? Even in home, landline, you have 2 wires only. One is earth wire, other is a signal wire. That's what the signal wire. Of course, there's a earth wire. Here also there's a earth wire. Correct? Because you are transmitting voltage. So if I wanted to lay a cable Chennai to US, some 15,000 kilometers, 8 wires, how expensive it will be? Initial cost. But instead of that, if I use only 1 wire telephone, 1 wire, it is cheaper. Initial serial communication, initial investment is cheaper, but data will transfer slowly. Okay? If I use parallel communication, data will be transferred faster but cost will be very high. 8 wires, 8 times more costlier. Long distance. So for long distance communication, note down, for long distance communication data transfer, we use serial communication or serial communication bus. For short distance transmission and faster transmission, short distance means use parallel communication. Even now happen. Inside your computer, you have a CPU, you have a memory, you have a hard disk. All these things are connected by a bus, communication bus. There they use parallel communication. Why? Everything is within 1 feet inside your motherboard. In motherboard, few inches away. CPU, memory, all this stuff, few inches away. So you can have there, the data is transmitted 64-bit parallel bus. You know that i7 processor, i5 processors are called 64-bit processors. That means there are 64 data lines, D0 to D63. That means I have my i7 processor connected to my RAM memory and also connected my CD-ROM. Correct? All these things you say parallel bus. This is parallel bus. This is parallel bus. This is my CPU. Correct? This is my memory. All these things are in my motherboard. What is size of motherboard? Less than a feet. So the distance, so there are 64 wires, but we want speed. Why? You are working at, what is your CPU speed? 3 gigahertz, 3 into 10 power 9. So many bits of data is transferred within 1 second. So you need a faster bus. So use parallel bus. Short distance, you use parallel bus. For long distance, what is short distance, long distance? Already we saw. Correct? If you are going to use this, we know that 40 meter. Correct? Inside vehicle 5 meter, 10 meter, 20 meter. Okay? So not more than that. Okay. Now that you understood what is the parallel bus, what is the serial bus. Okay. So sending data sequentially over a bus is called serial communication system. Data is transmitted bit by bit like this. At a time, transferring at a time is in the parallel bus. This is faster. This is slower. This is costlier. This is cheaper. Initial cost, I'm talking initial cost. Okay. Okay. Serial communication is slower than parallel bus, and the maximum speed. I'm talking about there's a communication system called RS-232C communication system, which was used in computers 1920s or 1920s to up to 2000. RS-232 communication, all computers you have. Backside, we are going to talk about the next class. Okay, RS-232 communication was used. The maximum speed is 9,600 bits per second. You can see here. This is RS-232C communication. Very popular in computers for more than 50 to 60 years. Between two computers, not inside the computer, between two computers. Correct? One computer here, next table, 10 meters away, within a building. One building to another building. RS-232 communication can work up to 100,000 meters. But it can transmit data only 9,600 bits per second. BPS, which is called a baud rate. This is what used even in telephones. Detail transmission, fax transmission. Telephone is a voice signal. Fax, we had no that time. Fax came more than 50, 60 years before. They were transmitting detailed data. They were using telephone wires. Voice also will go. Also the fax message, same wires from Chennai to London, Chennai to USA. Right? There the data was transmitted 9,600 bits, 9.6 kilobits. You see how slow it is. It was used for even computer to communicate within the building. Correct? Parallel bus use generally 3 to 4 meters. That time. For printer, all these things, not between two computers. But inside the computer, always use a parallel bus. Okay? For serial communication used for long distance because of lower cost and practical reason. And the parallel bus used for short distance and high transfer rate. Okay? Okay? I will stop here. I know that you have to go.
Sir, is that mean that all the safety-related items should be communicated by parallel communication?
No need.
No
Serial
need.
communication, CAN bus is a serial communication. All these buses, please note that all these buses are serial communication buses. In vehicle, we are only inside your ECU. Correct? ECU means there's a CPU, there's a correct embedded controller we call. Inside that, there you use parallel bus. But between the ECU, that's what this shows. All these buses are serial communication. Serial communication, this is sufficient. Correct? Parallel communication, you can go to 9 into 10 power 9, 3 into 10 power 9. Optical communication, optical fiber, correct, is a serial communication. But now serial communication improved tremendously. CAN bus itself, latest CAN bus 8 megabits per second. Latest CAN bus which is used currently. That is sufficient. I will tell you why. Correct? We don't need in gigabits for control, vehicle control application, whether even ABS, all these things. Because the ABS sends a command in microseconds. For example, I say that 10 MB speed. Correct? What is the information of this one? I want to transfer 8 bits, 10 Mbps. Right? So that means 1 bit will give 0.1 microseconds. To transmit 8 bit, how many microseconds? 0.8 microseconds. Your ABS transmitted a byte of information to engine controller, correct, at 10 megabits. CAN bus works now 8 to 10 megabits within 0.8 microseconds. Okay, this information, whether engine will respond, if a fuel injection is reduced within the second microsecond, if you apply a brake pedal, whether mechanical thing will move. Mechanical thing has a inertia. They respond in milliseconds, seconds. Generally, maximum seconds only. or milliseconds, sir. By sending a command in microsecond, nanosecond, no use. Higher the speed of the bus, you will spend more money on the hardware, software, correct? Using high-speed communication, you will spend more money. The electronic is costly. CAN bus controller, or if you go for high-speed communication, so waste of money because your mechanical system is not going to work. It has its own this one, correct? You know that engine can, what is maximum acceleration you get in engine? 0 to 100 kilometer. Torque test develop 3 seconds, 4 seconds. Even you inject the fuel, correct? Within 1 millisecond, it has burn and accelerate. Although it is not going to happen, correct? So for mechanical, because all mechanical systems are dead slow. They are like Kumbhakarna, correct? The electronics are working in microsecond, nanosecond. These fellows are working in seconds, millisecond. If you talk about big excavator, correct? It will not move. A 1000 HP engine, the crankshaft will not slow. What is a ship engine speed? Any idea? I think somebody is there from ship, no?
Jagan.
Yeah, 100 RPM, 200 RPM, because the 80,000 HP, the crankshaft weight may be hundreds of tons. Correct? The bore size may be 5 feet, 6 feet height. A person can go inside and come out. It works 100 RPM, 200 RPM ship engine. Okay, inertia. Right? So there is no need to have parallel bus in case of the vehicles. Even transfer. That's why they use serial communication. Okay. I stop here. We'll see Monday. Continue with the serial our buses like CAN, LIN bus, all those things. Monday, 3 o'clock will be. Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
sir. Thank you very much, sir.
Yeah. Thank you, sir. Thank you so much.
Before leaving.